Good morning, everyone. Welcome to my talk. Today I will talk about our implementation of a new console for virtual machines in CloudStack. My name is Wei Zhou. I'm currently working in Is Web in Netherlands, and I joined Is Web in 2012. Before that, I worked as a manager of a project based on Architecture for 2 years. And in 2013, I contributed the first 7 commits to CloudStack 4.0.2. I'm Cloud committer since 2013 and a member of PMC since 2017. You can reach me by my work mail or my Gmail. Out of work, I'm a father of 2 daughters. Our CloudStack team at Is Web have 10 developers and engineers from 8 countries. We have office in Amsterdam and in Phoenix in US and Bangalore in India. We are building, maintaining, supporting our public cloud and CloudStack private cloud in Is Web since 2012, and we started with CloudStack 2.2.14. We are running over 1,000 physical servers in 6 data centers in Netherlands, Germany, UK, US, and Singapore. We have around 3,000 commits to CloudStack, and we have many customized changes. So we are porting our changes to Cloud mainstream, and we will create more pull requests to Cloud mainstream. So I will start with discussion how to access virtual machines, like VNC, and introduction of current console of virtual machines in CloudStack. Then I will introduce our ideas and implementation, our improvement, and the end demo. So most of us should be familiar with this one. This is the current solution for in CloudStack, and this is the NoVNC console I'm going to present. How to access virtual machines. Normally, when we deploy instance, the first thing we normally do is trying to access the instance. So for the Linux servers, we use PIN, use SSH, and for Windows servers, we use RDP. All these ways depends on the assumption that the VM has network connection. So what if the VM doesn't have a network connection? For example, disk is broken, or operating system is broken, IP is not configured, IP is wrong, or the VM use private IP, so we cannot connect to it directly. For physical servers, we can access the console of the servers by this console, web console the vendors provide. For example, the Dell server we use ajax, HP we use INO. So, is there a way to remotely control a virtual machine like we do on the physical servers? The answer is VNC. So VNC is it use a standardized protocol named RFB to remotely access a server. It can transmit the keyboard event, also the mouse event. So we can remotely control the server. It was designed to access a server, but for now it's also supported by most popular hypervisors. For example, KVM, VMware, Zen Server, and example how to access console of virtual machines running on KVM. So when we start a VM in CloudStack, if we look at the definition file of the VM, we can find this part. It means it will provide a VNC server listening on the IP of the hypervisor, and the port is auto-allocated, and the password is the VNC password to access the VNC. So now, if we run VNC display, it will get this result: the IP of the hypervisor and the number. The actual port of the VM, VNC port of the VM is 5900 plus the number. In this case, is 5909. So now we are able to access the VM by IP and the port. There are many VNC clients you can use to access the console of the virtual machine. That's the example. We use TinyVNC. We input the IP and port here, and collect. And it will ask for the VNC password. Then we input the password we got in the definition file, and we get this console. So for the Xen servers and the VMware, we have the similar configuration, and also we can get the actual port by some commands. There's command on for Xen server, command on VMware. So the limitations: first, it requires a VNC client application, and the second, it requires the direct access to the hypervisor. So it means if the hypervisor have private IP, then we cannot connect to the VM. If we cannot connect to the private IP of the hypervisors directly. So the question here, how to access a virtual machine from CloudStack web interface? We have the VNC server, which means the VNC, the console of the virtual machines on the hypervisor. It's the hypervisor use private IP, and we have web client, which means the browser or a session of CloudStack UI. So it will first connect to a web server, and we need something here. It means from server it sends HTTP request, but to access the VNC server, it requires TCP connection. So we need a proxy which can act as the bridge of HTTP request and the TCP connection. It also acts as the bridge of the public internet and the private network. So that's the current solution in CloudStack. This is the console. But it's good. It provides a way to remotely access the virtual machine, and it can also handle the keyboard event and also the mouse event. And it's one clear. Sometimes it's lagging, especially for some Windows instance, and it supports only one session. So if we open the console from this laptop, and when we open the console of same instance on another server, then the current session on this laptop will be kicked off. So why is lagging? So if we look at the network activity of the browser, we can see that the request sent from the browser to the server 2 or 3 times every second. It's caused by the design of the web console in CloudStack. In CloudStack, we have a console proxy VM, which provides this console, and it uses ajax-based viewer as a web server, and also all the keyboard events and mouse events are handled by the cloud service in the console proxy VM. And from the when we access the console from browser, it sends a request to use polling. This framework was designed around 10 years ago, and at that time, Ajax is very popular. So that was the solution. And now we are wondering if we can use some other technology to replace polling. Polling is gone. And the answer is WebSocket. What is WebSocket? WebSocket is a standardized protocol. It's used for browser-based application to create two-way communication between the browser and the WebSocket server. So that is exactly what we need. For now, it's supported by most modern browsers and the mobile browsers. I will show a short example how WebSocket is working. Suppose we have a client, normally a browser, and the server, backend, and the server as this code. It will display all the updates of a file to the browser. It's similar to PLF. This is the command normally we use to get the next updates of file on Linux servers. And now we open the console of our browser, and we create a WebSocket connection to the WebSocket server. Now it's ready, and then we send the file name we would like to get update, and the WebSocket server will send all the updates to our browser. So, a few seconds, some new update, and more. So during this period, the WebSocket client or our browser do not need to send requests to the server. The server will proactively send updates back to our browser. So, how to access the server with WebSocket? We need a WebSocket proxy here, and at the beginning, the same. The browser will send FTP request to a web server, and the web server will send some response to our browser. And next, our browser will create a WebSocket connection to the WebSocket proxy. So, and next, the WebSocket proxy will start a VNC handshake to our Windows server. Then, if there are some updates with the Windows server, then it will proactively send back to our browser. In 2017, Sachin has implemented NoVNC console in his Google Summer of Code project. It used the NoVNC as the front end, and in cloud service, it used J2 server. And what is NoVNC? NoVNC is a web-based VNC client. It's mostly written in JavaScript, and it's very popular and used by many projects, including some our competitors, for example, OpenStack, OpenNebula, DigitalOcean, and it uses WebSocket instead of continuous polling. And more than that, it provides a better UI using HTML5. So this is a screenshot of the NoVNC console in Google Summer Code 2017. And the drawback of this solution, it needs extra parameter in CloudStack or our URL, and the codes are not completely tested and proved. So in our testing, is also not stable. So if we look at design, after some research, we found it might be caused by the JT web server and also the cloud service, because the keyboard event and the mouse event still be processed by the cloud service, same as our current console. So we are thinking if we can maybe use some other project or some other product to replace the JT web server. And at the end, we use Websockify. Websockify is also an open source project. It was part of the NoVNC project, and now it's a standalone project. It's written in Python. It's also used by our competitors, OpenStack, OpenAppner, and it's a WebSocket proxy. It can translate the WebSocket traffic between our browser to the WebSocket server to the normal socket traffic in the backend to the server in the backend. And it also supports encrypted WebSocket collection over HTTPS. So, here is a short example how NoVNC and WebSocket works. First step, download NoVNC from GitHub, and then add applicable rules, and at the end start WebSocket server. This command will download Websockify from GitHub, and then start listening on default port 680, and the traffic to local port 680 will be forwarded to the VNC console of the virtual machine on the hypervisor. So if we access the NoVNC page, that's the IP, listen IP, and the port, and the VNC password here, and we can get the same console. So how NoVNC and the Websockify is integrated into our system. First, I will introduce how a VM console works in Apache CloudStack. We have a WebSocket server. We have a managed server. We have some hypervisors where the VM are running, and when we set up a zone in CloudStack, it will create a console proxy VM, and it has two IPs. Well, mostly, if we do not take the local IP into consideration. It has a public IP. It also has a management IP. So when console proxy VM is running, it will send a command to management server to tell the management server that I'm running, and the management server will send back some information to the console proxy VM. So the cloud service in the console proxy VM will start console proxy agent, and when we if we try to access a console of a VM from our browser, it will send a request to the management server, and the management server will send command to the hypervisor where the VM is running, and the hypervisor will send back the answer to the management server. It will contains the listen IP and the port of the VM, and the management server will compose the URL which contains the public IP of the console proxy VM and a token. Token is encrypted information, contains host of the hypervisor and the VNC port, VNC password, VM UID, and the timestamp. So now, if we try to access the URL from our browser, it will send a request to the console proxy VM, and the console proxy VM will decrypt the token and access the host hypervisor IP and the VNC port with the VNC password. Now, this is how we access the console of the virtual machine. So before we integrate NoVNC and Websockify into our CloudStack, we first need to solve this problem: how to access multiple servers. Because in our example, we are able to access a single VM on the hypervisor, and in Websockify there is a token plugin. It can be used in two ways. First, a token file. So the token and the corresponding IP and the port are saved in the token file. OpenNebula use this way. And in OpenStack, it used a different solution. All this information are saved into database. So if we can, we pass the token from browser, and service will get the IP and the port from database. Then we can access the console of the VM, host of the console proxy, or host of the console proxy and the port, and also token. These two ways are both applicable for CloudStack because in OpenNebula and OpenStack, the NoVNC console is a service which is running on the main server. But for us, these servers are running on console proxy VM. So we are trying to fix this problem. At the end, we decide to redefine the path-stream here in Websockify. So all the information will be encrypted in main server, which contains some information, and decrypted in Websockify using a shared NoVNC key between the main server and the console proxy VM. So we made some change in the Websockify. And how it works? Same. Cloud service same, and NoVNC and Websockify are installed in console proxy VM. The same as before. And here, the command is different before. It contains more information than our current solution. It contains the shared key of NoVNC console. So when the cloud service gets the command, it will start the NoVNC daemon and the WebSocket server. Now, the same gets the VNC port, answer to main server, and compose the URL. Now it's different and get difference. So here is the URL which NoVNC provides, and parse is similar to the token. It contains some information: host port, client IP, timestamp, signature, and also the VNC password here. So access the URL. You will get the console proxy VM will send the NoVNC web page to the browser and start the VNC handshake by WebSocket server. Here, this is the NoVNC console we get. However, if we look at the source code of the iframe, we can see the actual URL of the NoVNC console. We will see that the password is here. The password is the VNC password, and it might cause some security risk. So we are trying to fix this. First, I will introduce how to connect to the VNC server. Suppose we have the client and the server, and the client starts the VNC handshake. The VNC server will send the highest IFTP protocol to the client. Client will send back the actual IFTP protocol to the server, and the server will tell the client the type of authentication and answer to use VNC authentication. And then the VNC server will send a challenge to the VNC client. When the VNC client gets challenge, it will encrypt the challenge using the VNC password. This is very important. And when VNC server gets the encrypted information, it will check and send back the result of authentication back to the client. And when it's done, it will start the VNC collection. So in the traditional NoVNC and Websockify setup, the Websockify is acting as a pure proxy, so it will forward the traffic from the NoVNC client to VNC server in backend. It means the VNC handshake is here, and in the VNC authentication, the VNC client has to pass the VNC password. So how to solve this problem? Let's see what our competitors do. And in OpenStack, you do not have no VNC password. Right? It means if you have access to the private IP of the server, we can maybe access the console of all the virtual machines of the hypervisor without any password. So I think it is a very big security problem, and I did see some requests in the OpenStack community, but still no response. And in OpenWebinar, it provides two solutions. First, add the password URL, same as I said just now. And the second solution, they pop up dialog to ask the users to input the password manually. So the customer has to get the password and input them manually. It's not convenient from users on the user interface. So, how to solve this problem? Well, if we can maybe move the VNC handshake between the NoVNC client and the VNC server to Websockify, then the problem can be solved. So, to achieve this one, I add some code in the Websockify server, so it will support the NoVNC handshake if we pass the VNC password, and also I changed the NoVNC so it's compatible with the Websockify and the modified Websockify, and both are has been uploaded to my GitHub. And now if we set up a WebSocket server with the VNC password, we can download the VNC from my GitHub and launch the VNC server with the listen IP and the port and the VNC password here. And from the web browser, we do not to pass the password anymore. See. the VNC password is not here. So based on the new modified Websockify and NoVNC, so I changed the code, I changed our implementation. There, the password is not here anymore, and it has been moved from URL to the path. So now it's encrypted. So in summary, we implemented a new console for virtual machines in CloudStack. It uses NoVNC as the web-based client, so it has better user interface because we use HTML5, and we use Websockify as a web proxy. So the continuous polling is not needed anymore, and also because we use modified Websockify, the VNC password is not visible for the users. So I've created 2 pull requests on our Cloud GitHub, one for the mainstream and another one for 4.11 LTS. If you are interested, please test it, and any suggestion and problem report I welcome. Demo. There are 2 options because WebSocket is not a secure protocol, so the security never depends on which HTTP protocol we use. If we create WebSocket collection over HTTP, then it's not secure. If we create WebSocket collection over HTTPS, then it's secure. So I will demo it separately. This is the Cloud dashboard. I will first demo the steps to configure unsecure NoVNC console. That's our dashboard. Sorry.
To set up unsecure NoVNC.
First, go to the global settings and change 2 settings. The access enabled to false. And we set the NoVNC console as a default console. And we go to infrastructure, system VMs, and destroy the current running console proxy VM. And the CloudStack will create a new console proxy virtual machine automatically. When it's running, then we are able to access the NoVNC console of virtual machines. This configuration are very simple, and it doesn't require the SS certificate and a DNS server to resolve the domain. So it's convenient for the cloud users, for the new cloud users to set up a NoVNC console. And to set up a secure NoVNC console is a bit complicated. Global settings. Change the console proxy.ss enabled to, and we need to change to URL. So if the URL start with star, then the URL of the VM will start with the IP of the console proxy virtual machine. Upload the SS certificate and also the domain of the certificate. Okay. It will take a few seconds, and after that, then the system VMs will be rebooted to work with the new SS certificate. So when the VM is running and the agent state is up, we are able to access the NoVNC console. So currently it's not perfect. There's still something need to improve. For example, in the NoVNC project, it doesn't manage the session, so there's no session timeout. If we open the VM console, it will. If we do not close the page, then it's always working. And because of this, it's better to add some reverse proxy. For example, using Nginx or Edge proxy to manage the session in the console proxy virtual machine. And it's also be nice to have a one-time token. If the token is used by one session, it cannot be used by another session. So even if we access the VM with one token, and then other cloud users or some attackers gets the URL of the console, it cannot access it because the token is removed and not available anymore. And also, well, it's better to have multiple NoVNC consoles. So that's it. Any questions?
Go on. Go ahead. Thank you. With the changes you have done, do you think it's possible to get rid of? So I have two questions. The first question is, with the changes, do you think it's possible to even get rid of console proxy VM because you can host the Websockify service on the management server itself? The second question is with respect to load management. So like when there are multiple users trying to access console proxy, CloudStack keeps track of what is the load of a particular console proxy VM, and based on that it can start additional CPUs. So in your implementation, do we keep track of the load as well?
For the node, it's we can enable the logging of the NoVNC and the Websockify in the console proxy VM. So if one session comes, and we can see some logging, we can see some logs in the system VM. I think for now it's that problem solution. And for the I was also thinking removing the console per VM and add a new service to provide the console proxy. However, it seems to be a big change to CloudStack. So for now, it's not implemented yet. But I was really thinking about it. That's one. NoVNC console as a service, so we can deploy on the managed servers or any one servers which has public connection.
Yeah, I didn't quite understand. You mentioned that it started out with Jetty being kind of proxy, and you switched to Websockify. So I have two questions. One was, can you explain kind of the evolution there? Or why you changed?
Well, the Jetty, you mean?
Yeah, from Jetty to Websockify.
Here. Because in cloud, in this design, in this implementation, there's still a cloud service running in concept VM, which handle the VNC authentication, handle the keyboard events. The cloud service still do a lot of things because it's implemented in Java, so we think maybe it's better to reduce the nodes of cloud service and move it to Websockify.
Okay. Yeah. So I thought originally it was because this is kind of a middleman, and but then you talked about Websockify and how you moved to basically terminating the DNC connection on the Websockify side, or in order to address the password issue. So you have Websockify actually making the DNC connection for the password issue.
Yeah.
Is that correct?
Yes.
So I was thinking that the Jetty web server might be a good solution for creating a proxy that could be fully featured. This leads into my second question. Now that we have a secure CA framework around the KVM agents, where the KVM agent and the management server have mutual TLS authentication, and the management server is actually managing a certificate CA, and it pushes the CA down to the KVM hosts. I think it would be really great to secure the VNC sessions with that CA and with those certificates. VNC and in Libvirt, there's the ability to use certificate-based authentication on VNC, but the client support for mutual TLS authentication is pretty slim, pretty thin. So that's something that I would be interested in looking at is, as far as the future enhancements to this, is to take those certificates that we already have on the host and have mutual TLS between the console proxy and the backend KVM servers. So from the client to the proxy, you have HTTPS, and then from the proxy to the KVM host, you have mutual TLS. And that would lock down, if your admin have access to the backend, the password is now no longer good enough to get to the VNC console on the individual VMs. And so that's a suggestion that might be interesting to look at.
I agree with you that that might be a good idea to take the CA framework in CloudStack into consideration. But we can maybe investigate in the future.
Yeah, I'm not sure if Websockify will support mutual TLS termination. And see if it might be something to develop.
We can investigate.
Wait, is there any way to not have the host and port in that URL? Because basically you're telling the end user what the internal IP address of my host is.
Yeah.
Which doesn't seem like
the IP. In the UI host and the port here.
So is that the internal?
No, this is actually the same as the IP and port of the URL, not the IP and port of the VNC server.
Oh, okay.
So it's the host the same as this, and port is also the same as this. So it doesn't matter. Actually,
Okay,
if we remove this one, it also works.
And would it be? I'm trying to think what it's doing. When it's secure, what would be the URL then? It won't be an IP address, or will when you secure it, obviously the point you go to is not going to be an IP address. It's going to be NQDN.
Yeah.
Will it still have to send the back IP address of that?
Here.
Yes, it's just repeating all the
Yeah, just actually the same as the
yeah.
and port here.
Okay, cool.
It's not needed actually. So if we do not pass the host and the IP, then NoVNC will pass the URL and get the host and host here. Yeah.
Now, I have another question. So you are essentially using Websockify and CP to convert the WebSocket traffic to TCP socket based traffic. Do you think we can further actually use a VNC desktop client with some tooling or service in between, which can again convert that WebSocket traffic to a socket? So you can actually not just use NoVNC with CloudStack, you can use a desktop client with CloudStack.
I think so. Maybe in the future we can support some SIM clients or some other VNC clients. But I didn't test it. Personally, I think it might work. And tomorrow, my colleague Jeffrey and Tina will talk about the lessons when we migrate 3,000 OpenVZ container to CloudStack. And there will be another room. So you are welcome to join. Thank you.